Hi everyone, welcome back. This is the final video in the first video series for the gas laws. We're going to be talking about Avogadro's law, but I'm going to start off with prefacing about Joseph Gay-Lussac. So Joseph Gay-Lussac was a chemist and physicist, and he, like Jacques Charles, who we talked about last time, worked with hot air balloons. So right kind of after Jacques Charles, Joseph Gay-Lussac also works with hot air balloons and essentially rediscovers what Charles found, but he just publishes it, so that's kind of why they share the credit for Charles' law. And then Joseph Gay-Lussac also discovered a pressure-temperature relationship, but I'll be discussing that in the next video. But the main thing is that he discovered the law of combining volumes, which is that gases at constant temperature and pressure combine in simple numerical proportions by volume, and the resulting product or products if gases also bear a simple proportion by volume to the volumes of the reactants. So in the same way that in a chemical reaction, like things combine in simple ratios, the law of combining volumes says that the volumes of the gases are also going to be combining in these simple ratios. And this simple ratio thing calls back to Dalton's atomic theory, like kind of early principles of chemistry. Things are made out of atoms, which are really simple bodies, and they'll combine in simple ratios. But Avogadro sees Gay-Lussac's law of combining volumes as well as what Dalton proposed, and he's like, hey, well, that would only be possible if equal volumes of gas had an equal number of molecules, right? Because, in these examples, they're different gases, but they're still combining in the same ratios. So he hypothesized this, but people actually reject his work. Dalton actually does, because Dalton thinks I don't think that hydrogen gas is H2. Like, he thinks that hydrogen gas would just be like single hydrogen molecules because they're simple gases. And so Avogadro's discovery and experiments weren't really as widely acknowledged into a law until decades later. So his law says that two equal volumes of a gas, if they're at the same temperature and pressure, contain the same number of particles, which could be either atoms or molecules. And you might recognize Avogadro from Avogadro's number. This principle helps us get Avogadro's number, which is like the number of molecules in the molar volume of a gas, and we basically use it to quantify every other number of atoms. Okay, so this is Avogadro's law formalized. So basically, volume is just proportional to amount at constant temperature and pressure. And we'll turn this into a kind of formalized law. Volume is proportional to amount, and then initial volume over initial amount should equal final volume over final amount. And this thing at the bottom, just remember, like, a mole is 6.022 times 10 to the power of 23 atoms or molecules. And I just put that there so you could just remember, like, I know I reiterate this a lot, but make sure you're using the right units. We basically always work in moles. There's not really that many other units that we would be using, but just as like a general reminder, those units that I talked about in the preface video to this entire series, make sure you're using those, because otherwise it's gonna get complicated and weird when we get to the ideal gas law. Let's try a practice problem with Avogadro's law. So at a certain temperature and pressure, 2 moles of nitrogen gas fill 2.5 liters of space. How much volume will the gas fill if 1 more mole of nitrogen gas is added? Okay, so what was our law? Initial volume over initial amount equals final volume over final amount. And at this point in the series, I hope you're seeing kind of the pattern with these laws. It's mostly just ratios. It makes sense that things would exist in a certain ratio if they're proportional to each other. So we don't really need to worry about the temperature and pressure here because they're being held constant. So let's just focus on the amount and the volume. So our initial volume is 2.5 liters. And our initial amount is 2 moles. And then our final amount is going to be 2 plus 1 moles over a certain volume. So now, again, it's time to pull out a calculator, or if you can do this in your head, I can't. I'm really bad at arithmetic. But so 2.5 divided by 2, and then times 3. Okay, so our final volume should be 3.75 liters once we, multiply everything by the denominator. So if 1 more mole of nitrogen gas is added, then that is our final volume. And we don't really need to worry about like the nitrogen gas or something, like that's just an added detail because, this thing applies to all gases, as Avogadro was saying. So yeah. Let me erase these. Or not. Okay. But these are my sources for this first video series, and I hope I'll see you back for the next video series, which is going to be talking about the ideal gas law, Gay-Lussac's own law, which I mentioned previously, and a few other things. Bye-bye.